Hi, this is mostly for Anna, but anybody else who was feeling like, okay, this was about as clear as mud, and I just want to maybe end up with an easier example, prove to you that if I take this polynomial right here, this polynomial I'm going to call p of x equals, and I'm just going to make it a quadratic right now, 3x squared minus 4x plus 2. It's just a trinomial. It's a three-term polynomial, right? And I divide it by x minus 5. Okay, the solution, I just want to show you why synthetic division turns out to be the same thing as evaluating the function at 5. Because if I take this polynomial, 3x squared minus 4x plus 2, I divide it by x minus 5, I will get a new polynomial, q of x, the quotient, plus the remainder divided by x minus 5. And now watch. If I just take this p of x here and I multiply everything here by x minus 5, okay, I've got x minus 5 here, x minus 5 here. If I multiply everything by x minus 5, I get q of x times x minus 5 plus r. Okay, now remember now we're going to let x equal 5. Then p of 5, okay, is going to equal q of 5, but who really cares about that? Because really, see, what we get here is a 0. So all of this goes to 0 plus the remainder. So therefore, the value of this polynomial at x equals 5 is going to equal, the remainder. So I can use, the point of this is that I can use synthetic division, well, or even polynomial long division, it doesn't really matter, but I can use long division to find the value of a polynomial at a given point. And I feel like I just wasn't making that clear in class. So I could just find p of 5. It's not a problem. To find p of 5, I can just plug and chug. 3 times 5 squared minus 4 times 5 plus 2, right? And so this is going to be 75 minus 20 plus 2. So I can just see here it's going to be 55 plus 2. So it's going to be 57. That's going to be the value of the polynomial at 5. But watch. Now watch this. This is the cool thing, okay? This is the really cool thing. Is I can use synthetic division. And when you do it right, I'm just again apologize for the class because somebody came, I got an interruption in the middle of the class. It just wasn't good. So anyway, this is the really cool thing. I can take this polynomial here and I can divide it by 5. What I'm really doing, first of all, let me do long division. Let me just make sure you understand this. I can divide this first of all by x minus 5. So we'll take x minus 5 and we'll do the full polynomial long division here because it's not that bad, right? X goes into 3x squared 3x times, right? We get 3x squared minus 15x. Polynomial long division, right? We've already done this before. Subtraction addition, we get 11x here plus 2, right? X goes into 11x 11 times. 11 times x is going to be 11x minus 55, and then we want to subtract this off, so add the opposite, and I can see the remainder is 57. So really what I get here is 3x plus 11. If I take this polynomial, so let me emphasize this one more time. If I take this polynomial, 3x squared minus 4x plus 2, I divide it by x minus 5, I will get 3x plus 11, right, plus 57 over x minus 5. Because that's what I get with the polynomial long division. Again, multiply everything by x minus 5. And what I get here is 3x squared minus 4x plus 2 equals 3x plus 11 times x minus 5 plus 57, or plus 57. And so once again, you can just see if I let x equal 5, if I let x equal 5, I will get here 57 equals 57. Okay, now let me do the same division problem using synthetic division. Let me do it one more time to show you using synthetic division. And just to emphasize that synthetic division also works if you do it correctly. I kept making arithmetic mistakes. Okay, so what we're going to do here, we're going to divide by 5. We're going to, really x minus 5, right? We're going to take 3x, oops, remember we're just using, so I'm going to do 3, negative 4, and 2, right? So I start out, I bring down the 3. 3 times 5 is 15. Okay, bring down the 11. 5 times 11, 55. Add those, I get 57, and that's the answer right there. So P of 5 equals 57, and it is very quick, very fast. It's actually quicker than your calculator. Now you can set a table in your calculator, put this polynomial into the y equal editor, where this is going to be your y, right? So y equals 3x squared. You would type that into your y equal. Then you would type in the second table set your table for whatever values you want to evaluate and do it that way. But this is good because look at how this, when I did the division problem, this gives me this. See, these numbers are important down here too because these numbers are the coefficient of my quotient. So notice when I divided x minus 5 into 3x squared minus 4x plus 2, I don't know if you remember when I was doing the long division, this was 3x right here minus 11. Do you see how these are the same? And that's going to become important. It's important in the next lesson. So just to show you one more time, like if I have a polynomial like this, something like this, maybe 2x cubed minus 3x squared plus, I'm so uncreative, 4x plus 5. Can't think of anything different, all right? This is the best I can do. All right, now, and we want to say something like, we want to evaluate this at 10, P of 10. Right now, I could do this. I could put this in my calculator. I could take 2 times 10 cubed minus 3 times 10 squared plus 4 times 10 plus 5, and I could come up with the answer. But the easier way to do this, the much easier way, is just to do polynomial long division. 2, negative 3, 4, 5. Bring down the 2, bring down the 2. 10 times 2 is 20. What do I get here? 17. Oh, I get 170, right? Is that right? 10 times 2 is 20. Negative 3 plus 20 is 17. 10 times 17 is 170. Okay, I get 174 here. And then 10 times 174 is going to be, what is that, 1740. And so my final answer is 17405. And I mean, I don't know. I think that's going to be right. Let's try it. We're going to take 2 times 3, whoops, excuse me, 2 times 10 cubed. 2 times 10 raised to the third minus 3 times 10 plus 4 times 10 plus 5. And yeah, I got 2015. Why did I do 3 times 10? Ooh, I forgot to square the 10. Okay, wait a minute. 2 times 10 raised to the third minus 3 times 10 raised to the second, that's better, plus 45, because 40 plus 5, right? Plus 45. Yep, 1,745. I can't show you my calculator, but that's it. So P of 10 is 1,745. Now this also becomes important just because if I take this polynomial here and I divide it, I get the coefficients here of, let's see, I got 2x cubed minus 3x squared plus 4x plus 5. If I divide this by x minus 10, that's what I've done with that synthetic division there, it will equal 2x cubed, that's important, 2x squared, excuse me, I gotta go down 1, 2x squared, see I'm getting that right there, plus 17x, the coefficient of my linear term will be 17, my constant will be 174 plus the remainder, and the remainder will be 1,745 divided by x minus 10. All right, so I need to know those coefficients in order to use Descartes' theorem. I need to know, and what's important about those coefficients is that they're all positive. They're all positive coefficients. So when I do this division, my quadratic becomes positive, my linear becomes positive, my constant becomes positive. That's important for finding the limits of your polynomial. So for example, with this polynomial right here, you know, this polynomial right here, this one right here, is a cubic, and I want to know where my zeros are. I want to know what the lower limit of my zero is and the upper limit of my zeros. I need to know where those zeros are. Okay, so that's it. Hope that helps you all, anybody who's interested, and sorry for the muddle just a little bit, and hoping that helps. Bye.